Hello. So today I'll show you how to extend a large language model LLM with real location intelligence using a model context protocol MCP server without relying on any access to the internet. So in this video, I'll basically show you an AI assistant doing location aware reasoning without secretly Googling the answer. In case you've ever asked AI about the location or perhaps what are the available mobility options to pick you from point A and drop you off at point B while visiting a whole new city and confidently gotten the wrong answer, then this video is definitely for you. So if we think about MCP today, it allows us to move beyond the static language models with their very limited knowledge and be connected to or connect the AI directly to domain-specific services, which gives more depth and more knowledge to the LLMs, things like location-aware services, for example. And in this short demo, I'll walk you through the structure of an MCP server built around my forever favorite location services APIs, and I show you how to test it, integrate it with an AI assistant like Claude desktop with the web access disabled to demonstrate tool-grounded location-aware reasoning. All right, let's have some fun and get started. So first things first, let's look together at the code repo, and in this README file, you will find an overview of all the location services I have included so far, and I will keep adding more into that. And soon after I commit the changes, you should be able to see the rest of the services I will keep adding as well. Then, along with that, also a step-by-step instruction on how to run and test the MCP server, how to configure it with Claude Desktop. If we scroll down all the way down here, you should see that. I will also share the repo link in the post description for your reference. So at a high level, when we think about building MCP services for your API, it comes down to two main components that I would like to highlight. So let me quickly go to the code here. So the first component is the tool definition. So as we look here, this is where you describe what the tool does and when it should be used, what inputs it expects. And this information basically helps the language model to reason about when a tool is relevant and how to extract the correct parameters from user prompt and so on. So here, as you can see, a name, description, input schema, and so on. Then the second component that I would like to highlight is the tool handler. So if I expand this public transit routing tool handler, this is where you define how MCP server actually execute the request, such as which API endpoint call, how to pass the parameters, how to even parse the response before handing it back to the language model. So in theory, when an AI application starts, it collects tools from all the connected MCP servers into a unified registry that the language model can access. And based on the user prompt, the model can then decide which tool to call and in what order. And that is quite important. And I will tell you why. So let's take a quick example. So if a user asks, how long does it take to reach, for example, Dubai Mall from my office in Innovation Hub at 5 p.m.? Then the model first thinks, what is the right sequence to reason this prompt? So the first, it uses the J-coding tool to resolve both locations, both Dubai Mall as well as the Innovation Hub. It understands that those locations needs to be resolved. Then it follows that with a call to either the routing or public transit routing, maybe, to evaluate available routes and travel times for that specific time and context. And obviously, without an MCP, the LLM would just rely on assumptions, perhaps, to answer this question, while with MCP, the response would be grounded in real services and real data as well. So that's the overall description of MCP, how it works, and so on. Let's run the show then. So let me get to the fun part and run the live demo. So first, let me build and start the MCP server. So if we go back again to the README file and go to the instruction on how to get this rolling, you will find here that the first thing that I need to do after cloning the repo and installing the dependencies and so on, I need to build this project. And basically what happens here, it will compile my code and generate some sort of an executable package of the MCP server. So basically I will just go with npm run build. This will generate a build folder here, which contains again the executable compiled version of my code. Then once we have the code built here, what I will do, I will share with you a very cool tool that I use usually to test and debug my MCP servers before I let them out in production. This tool is called MCP Inspector, and it's again like a Node.js based tool. So I often use it to quickly verify that everything works as expected. So which you can find the command here. So under the development for debug. So that's the demand that I will be running for the inspector tool. And ideally, this should launch the inspector tool right away. So let me grab the browser where this tool is running. So as you can see here, this is the MCP inspector tool that I just wrote here. So I will just connect to my MCP server since the server is built already. And the very first thing that it will do is I will just go list tools, and this will list down all the available tools in my MCP server. So as you can see here, every tool comes with the name and the description that already exists in my MCP server code. So this is the J-coding, reverse J-coding, and so on and so forth, the list of the services that I've already added. And the more services you add, or the more endpoints you expose in your MCP server, the more services you will see listed here. Let me quickly grab a couple of these and run a quick and direct query. So if we go to discover places, this gives me again like a tool to test out, right? So I will search for EV charging stations around this location, and let's see how this runs. So obviously the tool has run successfully, and it was able to bring back some data about EV charging stations available around the location I provided, which is successful. And of course, from the MCP server, you can control the language of the request and response and so on, and then whatever the API can expose, you can of course handle that. Let me also quickly test another service, which is quite interesting, which I'll be using the reverse J-coding service to return back speed limits at different locations. So again, I will just use quickly the same location. Then I will share the bearing value, which represents the direction of travel for, or the direction of the vehicle in real time in relevance to the north direction. And I will try to test this. So obviously the MCP server was able to return back some information about the speed limit at this location as well, given the bearing value, which I just shared. Cool. So looks like this did a great job so far. Hopefully the rest of the demo goes in the same direction. Now let me do something more interesting. Let me start configuring Claude Desktop so that I can use it as a client for my MCP server. So if I scroll down to the README file again, this is the section where I share more information about configuring the MCP server to know more about my services. Before that, let me run the MCP server itself. So, and this is all what I need to do to run the MCP server. So once it runs successfully, we should be able to see that, and this is happening. Cool. So I'm taking this configuration section, and I will go to my Claude here. And if I expand the connectors here, I will see that I don't really have any connection configured with my Claude. So what I will do right now, I will just add connectors, then I will go to manage connectors. This will take me to the settings of my Claude. I'll go to developer. Under the config section here, this is the configuration file of my Claude. I will just open that in VS Code so that I can add my configuration. So of course, there are so many parameters that you can pass here. For example, if I have any environmental variables that needs to be exposed to my MCP server, you can add this and so many others. But here I just prefer to keep it quite simple. This is the command which Claude will use to call my MCP server, and this is the location of my MCP server. Of course, if you happen to deploy your MCP server on whatever infrastructure, then those arguments will be quite different. So now I'll just save this, and I will restart my Claude. So let me restart Claude again and launch Claude back. Right, so now I just restarted and launched my Claude. All right, let's have a look again at the existing connectors. Oh wow, so I have my MCP server configured already with Claude. So if I go here to have more view on that, so as you can see here, those are the list of the tools that I was speaking about. So there's like Claude fetched that from the registry. So if I go back again to my code, just to show you the tools that we have defined. So we have defined this much of tools: J-coding, reverse J-coding, map image, traffic incidents, discover, public transit tools, and so on. That's exactly what we see here. You can also ask Claude to ask for permission before you use any of these tools, or you can just basically ask, allow them all at all times. So I'll just keep it as it is at the moment, and let's see how things look like. All right, so given that my Claude has been configured already with my MCP server and has an understanding of all the existing connections, so at this point I will go right away and explicitly disable the web search, just to make sure that all the answers provided by Claude are based entirely on the MCP tools, not the internet. So as you can see here, it has been already disabled, and I have my location intelligence MCP server services are only running. So I will run a set of prompts that require relocation awareness to demonstrate how the language model can now reason about places, routes, mobility, and services using MCP. So let me start with the very first prompt. So basically what I'm saying here, I'm currently staying at the Kempinski Hotel at Mall of the Emirates in Dubai. Can you show me the available public transit options to reach Dubai Mall right now? So if I ask this without MCP, the model would either hallucinate or just refuse to answer. But let's see what happens here. So obviously it was able to understand or to reason that there is a place that it needs to resolve, which is Kempinski Hotel Mall of the Emirates in Dubai. And here it asks me my approval to allow Claude to use this service from the MCP server. So I would just allow it. So the magic happens in the back end here, and it was able to resolve this. Then again, for Dubai Mall in Dubai, Claude is trying to resolve this. I will just allow it again. So it is using the service, as you can see here, from my MCP server. So it was able to resolve that into coordinates. So if I expand this, it was able to give me coordinates for this, and even the address and the place ID and so on. The same thing happens for Dubai Mall. It was able to retrieve the very much exact place that it was looking for. Then right now what is happening, since in my prompt I explicitly asked for the available public transit, either public bus or perhaps metro and so on, it's trying to use the origin and destination based on the resolved J-codes here and request public transit from the tools that are exposed from the MCP server. Cool. So obviously the magic is happening, and as you can see here, the LLM is able to have a new perspective, a new capacity to go and retrieve data from the public transit APIs. And it's giving me back a route summary, and this is the arrival metro station, and this is even information about which metro line that it will be using, the total journey time, including the walking, which is pedestrian routes as well. And that's like the metro ride duration is only 13 minutes. Wow, that's quite cool. And it gives me more details about the journey as per the response that comes from the public transit routing exposed through the MCP server. Isn't that cool? I guess it is. All right, so, and yeah, it asked me that this is the departure, and I need to obviously walk a little bit for 9 minutes from my hotel to the metro station. Then I will take the metro station, and those are the metro stops that I will pass by. Then there is a significant walk at the very end, the stretch from Dubai Mall metro station until getting inside. And look at this. This is quite interesting. So it even gave me a lot of context about my walk. And of course, I cannot walk for 26 minutes in Dubai in the month of July, for example. So it even gives me a relief saying that this is an air-conditioned walk away from the metro station to Dubai Mall. Just imagine that you're building a narrative around that, or a multimodal response from on your LLM or your Gen AI client to automotive customers, or even journey plannings and so on. And there's also just a few tips on the route for the walk away. Also things that has to do with the payment cards as well. So this is quite useful here. All right, then let me even do something that is quite interesting. So it gave me some information about the null card here, but let me ask if I can get more information about the service provider, which often very useful for subscriptions and so on. So I will ask the model here if it does know any information about the service provider, so that I can again make use of this information, perhaps log into their website. And I believe this information is also returned in the public transit response. So if we go up here and just look at the response, obviously, so here is a very structured JSON response that the model was able to fetch information from. If I go all the way down here, so as you can see here, oh, this is quite cool. So even the response from the public transit service sends back information about the service provider, which the model was smart enough to fetch and share it back with me, which happens to be quite useful. Well, that is escalating quite quickly. Let me share something quite interesting. So what I will do right now, I will ask about national Saudi short address in Arabic. So here I'm asking the model if it can determine where exactly this national Saudi short address in Saudi. Let's see what happens here. So obviously, if I have a J-coding service that supports this kind of addressing, it should be able to bring back some useful information. Oh wow, so it's even responding in Arabic, which is fancy enough for me. So obviously, it has taken this text and understood that I'm looking for an address in Saudi, and it asked me to allow the service to bring back some information about that. Oh boy, that is quite cool. So it was able to resolve this national Saudi short address and respond back to me in the language which I preferred in my prompt. So it gave me information about the city, which happens to be Riyadh, also the district, which happened to be Al Murabba district, the street, and even the postal code, which is equivalent to this national Saudi short address. And also it asked me if I need any directions or so. So no internet, no cheating. All right, so let's see how confident it still feels to whatever happened next on the MCP server. So let me ask the MCP server another question that has to do with location reasoning and so on. So obviously, I will ask the MCP on how long would it take me to drive my car. Actually, you know what? Let me make it even more exciting. Driving an EV truck from an Amazon warehouse depot in Riyadh to this location. And I mean, or I would like the model to refer by this location to the national Saudi short address that I've just shared. Let's see how smart it is. And I will give it even more context. So I will tell the service that I need to arrive tomorrow at 10 p.m. All right. So whatever happened next is on me and the MCP server, because remember, we switched off the web access, so we are 100% relying on our MCP server and the exposed tools. Okay, so it is cool enough. So obviously it understood that I need to go either from or to this national Saudi short address that I've shared earlier. And it also understands that I need to go from Amazon warehouse depot in Riyadh, Saudi Arabia. So it's again asking for my permission to do a J-coding request. All right. Okay, so it understood that I will be driving the truck and this is the origin and destination. Wow, that's quite impressive. So now it's using a new tool, which is the AB routing tool. And it gave me a very detailed response with the instructions and turn-by-turn directions. Oh, wow, that is quite impressive. So I'm using an EV truck route here from Amazon warehouse in this district in Riyadh to this place in Al Murabba district in Riyadh as well. And this would take me obviously around 1 hour, 13 minutes. Look at that. Look at that. So the base driving time is 38 minutes, and with traffic considerations, it goes up to 73 minutes. So obviously, it even factors in traffic in the route that I've just asked for. Then it gives me a lot of information here. So this is great because it even proposed to me when I need to depart so that I can arrive at the designated time according to the traffic and so on. So this means that the routing service that we have exposed, it is not just traffic aware, but it is also truck and traffic aware at the same time. That's quite cool. All right, so I will then take it to a next level. So let me type this. So by the time I arrive there, since I will be driving an EV truck, so let me just quickly correct that. By the time I will arrive there, I would need to charge my EV truck and wondering what EV charging stations are available. Around this destination. Okay, so this will give context to the LLM to go and search for EV charging stations around this place, which should be open by the time I reach there. So let's see how smart the model will react to that. So what I'm doing here literally, let me first look at this. So it is going to the discover places endpoint with looking for EV charging stations around the destination location, which is exactly what I would think about doing. So here, basically, I'm actually outsourcing the range and anxiety officially to the MCP server. And this is kind of an experience or planning that I wish my car could do on its own on my behalf. This is really cool. Can you imagine how many use cases we can enable and we can cover with this? So it was able to go back and search for the nearest EV charging stations around, again, this national Saudi short address. So this is a mainstream of intelligence here, by the way. So national Saudi short address integrated, EV charging stations, truck routing, traffic aware routing. So it even listed down the response by distance. So this is the closest from my destination, which ideally should be open at this particular time, the moment I reach there. So, and the LLM is smart enough to give you more context about some important nodes and so on, without bothering much about building this context. All right, so now I'll be asking one of the most important questions, and to me, this is obviously one of the most critical uses of AI. I will ask about the restaurant. So, most likely, I'll also need to rest and grab something to eat. And I'm craving Indian food. Can you recommend a few well-rated Indian restaurants near the destination that are likely to be open when I arrive? So let's see how this will come back. All right, so yeah, see how smart it is. So again, it's trying to discover Indian restaurants or Indian cuisine restaurants around this place again, which is fascinating. All right, oh wow. Again, it's smart enough to go and fetch information around around this place with all the top-rated Indian cuisines. Again, sorting them by distance, the closest first. So as you can see here, all the information, and I'm 100% sure that this is grounded on opening and operating hours, ratings, and so on, as long as you expose them via the MCP server. And it even it's now more interactive. And imagine if you're building a voice-enabled bot in your car or in your customer apps, which interacts back with you. So here it recommends if you would like to see a route from this destination to any of these restaurants so that you can prompt back and so on. So I will just, the very last thing that it just came to my mind, and if I would like to integrate it, I will just ask the model to see the multimodal capabilities that it is capable of. So I will ask it, can you display a map of this location for just for my reference maybe? Let's see. So obviously what I'm asking here is, again, not a text response. It is more than that. I need a map display. I need a map image. So here, what I'm trying to do, one of the services that I've exposed to my MCP server is map image. So it's taking, again, the coordinates of my national Saudi short address where I'm asking for a map image, and it is intelligently trying to extract this map image for me. So let's see if it really responds back with something. Oh my Lord. This is awesome. This is super cool. So it was able to really fetch a map right away, even in my local language, which I should have full control on top of that from the parameters in my MCP server. But it was able to really get me like a map around the location that I was looking for. And I guess that's really what I expect and what happens when an LLM stops guessing. It does stop all the guesswork and start using real tools, real services, real data, and so on. So to wrap things up, what we have seen is just one single example of what becomes possible when using LLMs and connecting them to real domain-specific capabilities through MCP, and think of the likes of location services, healthcare, logistics, whatsoever else. And whether actually it is mobility industry, logistics, smart cities, energy, healthcare, infrastructure, whatever it is, MCP allows AI systems to move beyond the static knowledge, and that's exactly the morale behind the whole demo that I've walked you through today. And it starts reasoning with live services and structured data, real-world constraints that could be very, very special or specific to your business and so on. And this approach opens the door to building assistants and agents as well that are not only conversational but also reliable, explainable, as you've seen with me, and production ready as well. You can build even agents that can take one of these services and do execute other as well. Well, thank you so much for your time. I know I've taken a little bit of your time of the day, but it was a good chance to wish you happy holidays and Christmas. And I would love to hear your feedback. Please feel free to share your thoughts or questions in the comments, and I will look at them. And if you are working on something interesting or think MCP and location intelligence could help you build something useful or impactful, do not hesitate to connect. I'm always happy to exchange ideas and explore what's possible. Thank you so much. See you in the next video. Bye-bye. Cheers.